let's say we have some very simple data, and we want to compute the sample standard deviation of, and here's the data, 1, 0, 3, 3, and -2, rounded to the nearest hundredth. This is actually a two-step process, but it's two simple steps. Step 1 is to calculate what's called the sample variance, which is actually the square of the sample standard deviation. And here's the formula. The formula is n. Now in statistics, n always stands for the sample size. So I'm going to write this down. N equals sample size. And the sample size is simply the number of numbers. That's all it is. So we have 1, 2, 3, 4, 5. So this tells us that n equals 5 because we have 5 points of data, 5 numbers. Okay, so if n is 5, n minus 1 is 4. So this would be a 5, this would be a 4. Now here we have an x squared with a bar over it, and here we have x bar, which is squared. These mean different things. This means the average of the squares, and this symbol here means the square of the average. So that might seem a little bit complicated. We're going to take 5 divided by 4, and then we're going to multiply it by this quantity, which is the average of the squares minus the square of the average. But here's why this is a hack, and here's why this is very simple. There's no summation notation involved in this. And it's my experience that students of elementary statistics despise summation notation. I don't think there's anything wrong with it. In fact, I think it's a very good little bit of notation, but I know students despise it. And so if I know students despise it, well, then why not show them a hack, which is what I'm doing. So the second step would simply be to take the square root of this sample variance to give you the sample standard deviation. And this saves time on exams, big time, and it's easy. And the thing is, your professor may not actually know this unless they're formally trained in statistics. Your professor might not know it, but if your professor has formal statistical training, of course they'll know it, you know. So what I want to do is I want to show you how to calculate this sample variance step by step, which is step 1. So the very first thing we do is we make this little table, right? And I read the data off to you before, but we have this simple little table, and that's what we're going to do. And there are 5 pieces of data, 1, 0, 3, 3, -2. Now this I actually stands for an index. And this index represents the time order in which the observation was recorded. So this means that the first observation to be recorded was a 1. The second observation to be recorded was a 0. The third observation and the fourth observation to be recorded were both 3. And the fifth and last observation to be recorded was a -2. And since the highest index is 5, that's the sample size, n equals 5. Okay, so that's the sample size. So we know we're going to put a 5 in here. I'm going to use a different color. We're going to put a 5 in here. And this 5 minus 1 is 4, so we're going to put a 4 over there. So right away, this is going to be 5/4 times. Now we have to find the average of the squares. So what I did was I made a little column for the squares. See, 1 squared is 1, 0 squared is 0, 3 squared is 9, another 3 squared is 9. Now, some people mess this up. Negative 2 times itself is positive 4, because a negative times a negative is a positive. What I've seen students do is they screw up the sign on exams and they write negative 4, so don't do that. Negative 2 times itself is a positive 4 specifically. So in order to get the average of the squares, all we do is we take 1 plus 0 plus 9 plus 9 plus 4 and divide that by 1, 2, 3, 4, 5. So let's do that on the calculator and let us see what we get. Now, I do want to remind you that the rounding instructions did say to round this off to the nearest hundredth, right? So always keep the rounding instructions in mind. So I'm going to get my handy calculator out here. Now I'm going to put the numerator in parentheses, because why wouldn't you put the numerator in parentheses? It's its own thing. So 1 plus 0 plus 9 plus 9 plus 4, and then I close the parentheses, and then I hit the divided by button, and then the 5 button, and I hit the equals button, and I get 4.6. Right? So that 4.6 goes here. Right. So hopefully that is clear. And now the next thing we have to do is we have to find the square of the average. But before we can find the square of the average, we have to find the average, x bar. So the average, which is also going to be a numerator divided by 5, is 1 plus 0 plus 3 plus 3 plus negative 2. And I'm going to put this into the calculator. I'm going to show you how I do it. So I'm going to hit the parenthesis button, and I'm going to go 1 plus 0 plus 3 plus 3 plus. Now I'm going to hit the negative button, which is different than the minus button. Please, everybody, recognize that the negative button is different than the minus button. Negative 2, and then I'm going to close the parentheses, and then I'm going to divide by 5, and I'm going to get 1 exactly. Now, when I get 1 exactly, it makes me want to do it over again just to play it safe. So we go 1 plus 0. I know I don't have to go plus 0. Plus 3 plus negative 2, close parenthesis, divided by 5, and we do get 1 exactly. Okay, so it worked out simply. Okay. So that means in this particular simple case, this is going to be 1 squared, because it says the square of the average, right? In fact, maybe I should write this down. So x bar squared is equal to 1 squared, which in this case also happens to be 1 in this nice simple case. So how do we deal with this? Because so far you might be saying, well, it's not that much of a hack. There's still work. Well, yeah, there's still work, but at least you're not dealing with summation notation, which I know the average Stats 1 student hates. And I can get you out of summation notation in a lot of different ways as little hacks. I don't know if your professor will like that, but it's true. So what we do is we hit the parenthesis key. I just broke my pencil. So we hit the parenthesis. So now what we're doing is we are evaluating this expression here. This top little expression. So we hit the parenthesis key, and then we go 5, and then the divided by button, and then 4, and then we close the parenthesis. So this here is that. So it should be pretty clear. So I'm going to just circle this. Oh, this is a regular pencil. So this is that. And then we're going to hit the times button. And then we're going to hit the parenthesis button again. And then we're going to hit 4.6 minus button. Now, I know 1 squared is 1, but you might have a different number here. So I want to show you which buttons to press because that's just the kind of teacher that I am. So I'm going to hit the x squared button anyway. And then I'm going to hit the close parenthesis button and then the equals button. Because if you had another number there, you would have to square it anyway. And what I want to do is I want to show you how this relates to this expression. So we have the 5/4 parenthesis 5 divided by 4. Done. There is multiplication here. That's what it means implicitly. So parenthesis, 4.6 minus 1, and you hit the x squared button and it squares it. Now I happen to be using the Casio. Let me see, which one is it? It's the FX 300 MS. I just looked at it. That's what it is. Now, I love this calculator because the Casio company, which I own no stock in or anything like that, I just happen to love this calculator, just laid out a calculator that's great for college math because the most common buttons that you're going to press are actually buttons on the calculator. You don't have to go in through these menus like these expensive graphing calculators. You have all these menus. So I do happen to recommend this calculator to my students, and I have no stock in the company. And it's really what you see is what you get, you know? So let me put this in, and I'll put this in for you. Let me make sure it is in the frame. Okay, so we're going to go parenthesis 5 divided by 4, close parenthesis, times parenthesis 4.6 minus 1. Hit the x squared button, even though you don't need to in this case, because 1 squared is 1. Close parenthesis, and then the equals button. And we get that the sample variance is equal to 4.5. Now, I want to be clear that this is the sample variance. But we're not done yet because the problem didn't ask for the sample variance. The problem asked for the sample standard deviation. That's what the problem asked for, not the sample variance. So to get the sample standard deviation, we actually take the square root of s squared. But on the Casio, this is so simple. What you do is you hit the square root button, and then you hit the answer button. And the answer button will recall the last answer. And you hit the equals button, and you get 2.1213. But the instructions say round to the nearest hundredth. So to the nearest hundredth, it would be 2.12. So S is the square root button, the answer button, the equals button, and that gives us that the sample standard deviation is equal to 2.12 rounded to the nearest hundredth. And that is the final answer.